Question 3. Benzoic acid prepared from ethyl benzoate. There's a reaction there. Add 5 centimeter cubed of ethyl benzoate. We've been given a density and an MR and a volume. So density is mass divided by volume. We've clearly got to work out the mass of ethyl benzoate, otherwise we wouldn't be given density and a volume. To 30 centimeters cubed of aqueous 2 mole decimeter cubed sodium hydroxide. So we've been given a volume and a concentration, so we need to work out moles there, because concentration is moles divided by volume. We could also work out number of moles of either of those, because we've got the formulae. Add a few anti-bumping granules and attach to a condenser to the flask. Heat the mixture under reflux, so you're going to heat it in a prolonged manner, so heat it for a while. In actual fact, you're going to heat it for half an hour. It tells you how long you're going to heat it for to ensure the reaction completes. Allow the mixture to cool. Pour 50 centimeters cubed of hydrochloric acid into the cool mixture. Filter off the precipitate of benzoic acid under reduced pressure, so you're going to use vacuum filtration. Suggest how the anti-bumping granules prevent bumping during reflux. They prevent large bubbles from forming. Show by calculation that an excess of sodium hydroxide is used in this reaction. Right, we're going to have to do some calculations. We already mentioned that we've got a volume and we've got a density of ethyl benzoate. So density is mass divided by volume. Let's work out the mass. So density 1.05 equals the mass divided by 5. Mass is 1.05 times 5, 5.25. So I've got 5.25 grams of ethyl benzoate. Now with the same thing here, so centimeter cubed and volume, so I've got concentration equals moles divided by volume. That should be an equals, sorry. Concentration equals moles divided by volume. So 2 equals moles divided by 0.03. Look what I've done there, 30 centimeter cubed. I've converted that into decimeter cubed. It needs to be in decimeter cubed. Concentration is moles divided by volume in decimeter cubed. So I've taken centimeter cubed into decimeter cubed, a small unit into a larger unit, centimeter cubed into a larger unit, decimeter cubed. I've divided by 1,000. So 30 divided by 1,000 is 0.03. So 2 equals moles divided by 0.3. Moles is 2 times 0.03, 0.06. Now I've got a mismatch because I've got 5.25 grams of ethyl benzoate and I've got 0.06 moles of sodium hydroxide, and I need to compare the two to answer the question, show that sodium hydroxide is used in this reaction. But I've been given the MR of ethyl benzoate and I've got the mass, so moles is mass divided by MR, otherwise I wouldn't be given the MR. Moles is mass divided by MR. So moles is 5.25 divided by 150, 0.035. So I've got 0.06 moles of sodium hydroxide, I've got 0.035 moles of ethyl benzoate. I've got more sodium hydroxide than ethyl benzoate, so I've shown that and got my 2 marks for 3.2. Suggest why an excess of sodium hydroxide is used. That's to make sure that all of the ester reacts. So we've got a reaction here of an ester. It tells us that we've got an ester, ethyl benzoate. So you could say to make sure that all of the ethyl benzoate reacts. Suggest why an electric heater is used rather than a Bunsen burner in this hydrolysis. We've clearly got something that's flammable. So one of the reactants or the products may be flammable. State why reflux is used in this hydrolysis. So it doesn't allow any of the reactant to escape as a gas. So what you've got with reflux is you've got a flask, but instead of just heating the flask and allowing the gases to escape, you've got a condenser above it, so that any gases that do escape go into the condenser, cool down and drop back into the flask, and so carry on reacting. Write an equation for the reaction between sodium benzoate and hydrochloric acid. So sodium benzoate is, you've got a benzene ring with COONA. You've sort of been given that in the equation here. Benzene ring with a COONA. You don't need the charges on there, and you can write this as C6H5 if you prefer to. 6 carbons in a ring, and there's a hydrogen on each of these. Or I suppose you could draw it out as a ring with a COONA. I preferred to write it as C6H5COONA and HCl. So you're going to get NaCl and you're going to get benzoic acid, this is called. So it's a benzene ring with a carboxylic acid. Suggests why sodium benzoate is soluble in cold water, but benzoic acid is insoluble in cold water. Sodium benzoate is soluble because it's ionic. So you've got a clue here that you've got a plus and a minus charge here. If something's ionic, it tends to dissolve in water because water has got polar charges, because the oxygen is more electronegative than the hydrogen, so you get delta pluses on the hydrogen and delta minuses on the oxygens in water, and so something that's ionic can form intermolecular bonds with that and tends to dissolve, whereas benzoic is insoluble because it's not polar, and the benzene ring is not polar either. So the benzene ring in this benzoic acid is not polar. The COH part is polar, but the benzene ring is not polar, so a large part of the molecule is not polar, whereas sodium benzoate is ionic.